So today we're going to talk about the inverses of linear functions. Inverse means opposite. So we've talked about how inverse operations like adding and subtracting or multiplying and dividing, etc. So inverses are the opposites. So an inverse relation is a set of ordered pairs obtained by exchanging the x-coordinates with the y-coordinates of each ordered pair in a relation. If 5, 3 is an ordered pair of a relation, then 3, 5 is an ordered pair of its inverse relation. And we're not going to get into this deeply, but one reason they're using the word relation instead of function is sometimes the inverse of a function isn't a function. It's still a relation, because you remember, like, relations are the big picture, all of the things. Then functions are a specific kind within that. But there are times when we find the inverse of a function that the inverse is still a relation, of course, but not a function. So that's why this definition is just talking about relations. So first, find the inverse of each relation. Okay, this is super hard. It says exchanging the x-coordinates with the y-coordinates. Ready for this? So we take these two and we flip them. That's right. You move the negative 10 to first and the 4 second. We're changing the y to an x value and the x to a y value. Then we do it again. Negative 19, 7. 17, negative 5. 11, 3. And you do need to put parentheses around all your ordered pairs, and it's best to put commas in between them, but I'm not going to require you to do these squiggly brackets around the whole thing. Okay, with a table, we'll do the same thing. So right now the x is negative 4, the y is negative 13, so we'll flip that and make it negative 13, negative 4. Here the x is negative 1, the y is negative 8.5, so we flip it, make it negative 8.5, negative 1. We flip this, so 0.5 becomes first and 5 second, and 6.5 first and 9 second. Okay, now those really are as easy as they seem when you're trying to find the inverse of ordered pairs. You just flip the order of the numbers. Now it's a little more work when we're actually trying to find the inverse of an equation. But I've got the steps laid out for you here to find the inverse of a function in its equation or function form. If needed, we'll first replace f of x with y. Remember, y and f of x mean the same thing. This is just called the function notation when they write f of x. So if it's already y, nothing needs to be done. But if they write f of x, they don't want to change it to a y. Then you'll swap the x and the y. So tell you what, let's go ahead and do these first two steps on this first example. So this one does say f of x, so I'm going to replace that f of x with y. Then, just like we're swapping the x and the y values, these ordered pairs, we're going to swap the x and y variables right here and make this x equals negative 1/2 y plus 11. So the next step is to solve the equation for y. Okay, so here's where the work gets a little bit tougher. Those first two steps are very straightforward. You just change f of x to y, swap the x and the y. Now we've got to get y by itself. So x is by itself right now. We're going to try to rearrange it so that y is by itself. So I'm going to subtract 11 from both sides first. And I need to divide both sides by negative 1/2. Because it's negative 1/2 times y, so I'll do the opposite and divide. you need to remember that dividing by a fraction is the same as multiplying by its reciprocal. So we're really multiplying both sides by -2. So we have -2 times x minus 11 equals y. And I'm going to go ahead and distribute that -2 through and make it a plus 22. And our final step is to replace the y with f to the -1 of x. So this represents the inverse of f of x, because this is its own function that we started with. We're creating a new function that is the inverse of f of x. And you don't have to write it on the left side like I did. If you wrote -2x plus 22 equals f to the -1 of x, that's completely fine. So remember these steps. We've got a couple more examples on the back. I hope will help you sort it out. Okay, step 1. They did write it as f of x, so I changed that f of x to a y. Now, we add 8 to both sides. No, sorry. See, this is why you gotta pay attention to the steps, or you're gonna make a mistake like I just did. Step 1, we changed f of x to y. Step 2 is swap the x and the y. So now, we're going to get y by itself. So I'll add 8 to both sides. And I'll divide everything by 4. So I get y equals, I'll just write this as x over 4 plus 8 divided by 4 is 2. And then my final step is to change that y to be the inverse of f of x. Okay, last example. This one, they don't have an f of x, so we don't have to change anything. It's already just y. So we'll go ahead and jump to step 2, which is a swap where the x and the y are located. And step 3 is we want to get y by itself. So I'll subtract 4x from both sides. And you can write this as -4x plus 15 or 15 minus 4x, whichever you prefer is fine. Then we divide everything by -3. So you can do it like I did up here and just divide the whole thing by the number and then split it up and say the first one divided by 4 plus the second one divided by 4. Or you can do what I wrote here. It's the same thing and just actually write it separately because we're dividing every term by -3. So here it cancels. 15 divided by -3 is -5. And then, since these are both negative, -4 over -3, it becomes a positive 4/3 x. My final step is to write this as the inverse of f of x equals -5 plus 4/3 x. Or, if you had at the beginning made this -4x plus 15, then the answer would just look like 4/3 x minus 5. And that also is correct. So either one of those would work. Okay, last thing I want to try to explain. I think B is the easiest one to show this. I want to show you how the inverses really are doing the opposite of what the original function did. So I want you to think about this function right here. If we plug a number in for x, the first thing it would do to that number is multiply it by 4. 4 times whatever number we plug in. After that, it would subtract 8 from that number. So it would multiply by 4, then it would subtract 8. But over here, what they would do is they would divide by 4, This doesn't work as well as I think. Okay, hold on. Let's go back to this form. Now, there's nothing wrong with this form. I just think it'll be easier for me to illustrate what's going on if we look at it before we simplify. So if we look at this version right here, you plug in a number. The first thing it would do to the number is add 8, and then it would divide by 4. So it's easier to see here how it does the exact opposite of what we did at the beginning. Here we multiplied by 4, then subtracted 8. Here they added 8, then divided by 4. So the inverse functions are doing the opposite of what the original functions do.